Hi there, folks. Hope you're doing well. Shawn Willsey, Geology professor here with you. I am currently in the city of Prague in the Czech Republic. We'll be on our way today back towards the States to New York City, where we'll spend a few days before we head back to Idaho. I've been following the situation in Iceland closely, along with many of the rest of you, I'm sure. And I apologize I wasn't able to get to any updates during my trip. Just, fast-paced, things happening all the time. And so just not a lot of time to put together one of these updates, but I have been keeping track of things that have been transpiring there, especially with the help of Amanda Joe, who's been sending me regular emails. So appreciate her for doing that. But I thought I'd have a little bit of time today before we have our plane flight. So it's about 6 a.m. right now, Iceland time. It's 7 a.m. here in Prague. So I thought I'd put together a quick little update here, find a little corner of the hotel to send you a little bit of an update, share a little bit about what's been going on the past week. This might be as much for myself as it is for any of you in terms of just processing what's been happening so far and just digesting all the events that have transpired over the past week or so. So thanks again for joining me. And let's just get right to it. The way I'm going to do this video is a little bit different. My laptop setup is a little bit different than what I use in the office, and so you won't be able to see my little head at the bottom, but you should be able to hear me. So I'll just put this part together, this intro, together with the rest of the update, and everything should work fine. But I just wanted to say hi to everyone. Hope you're doing well, and let's get right to it. Okay, you can see here with this webcam from live from Iceland where the current state of activity is at. You can see here that the activity that began on March 16th as a fissure eruption, several kilometers long, has now been constrained to just a few isolated vents forming spatter cones. A little hard to see the spatter cones because it's still a little bit dark there. 6 a.m. in Iceland, the sun's just beginning to rise here in the next little bit. But you can see more or less the size of these things and just sort of the recent activity. Looks like there's essentially 3 vents, at least based on this camera here. So just a few vents that are still remaining active. So the lava output has decreased over the past week or so. During the day, we've had some of the viewers on Live from Iceland have estimated the size of these spatter cones as maybe being as tall as 30 meters or so. That's unconfirmed, but those are some good guesses based on some folks that have just looked at the amount, how high I think the lava's been ejected, and then there's been a few times when there's been people down here in the foreground area and just sort of playing some games with the numbers and estimating the height of these cones. So we've had a good week or so of eruptions that have produced some really nice cones here. I guess it's been almost, 2 weeks? The 16th? Yeah, it's something like that. Week and a half, I suppose. And so we've got a couple of spatter cones that have been generated from this eruption thus far. Let's look at let's go to Google Earth here. And my normal version of Google Earth is not available with my laptop, but I was able to put together a few things here to help you. This does not show the berms, and because I have to use the laptop keypad as a mouse, it's a little bit wonkier for me to move things around. But the lava flow, we have the vent that's opened up here. And remember, during the initial phases of the eruption, we were focused on this northern branch flow that was heading off to the west. Luckily, that did not impact either the pipeline or the Blue Lagoon Svartsengi power plant area. This flow lobe down here was not a concern because it was sort of a dead end running into these hills. Wasn't really going to go anywhere. And then as it wrapped around this shield volcano here, this flow became the one probably of most concern because we had this branch of it heading down towards the coastal road and then possibly the sea. And there was concern during the first day or two of the eruption that this thing might advance all the way to the ocean. When I last updated you last Tuesday, this thing had stalled out and it didn't look like it was going to make its way to the ocean. But sometimes these lava flow channels and lobes can move forward in fits and starts, so they may stall for some period of time, but as long as there's still lava supply that's coming into them, they can still move forward. But this one has completely stopped. And so over the past week, what's happened, and again, you can't see the defensive berms here. I haven't put those on here, but I think you more or less know where those sit. And of course, right about here, let me zoom in just a little bit here. That's probably pretty good. We have the greenhouse, and so we have one segment of the defensive barrier that wraps around the north side of the greenhouse. And then right here where you see this little notch in the flow field based on this blue outline here, there was another segment of the defensive berm or barrier that came down this way. And this is where the lava really started to slow down, but also started to accumulate. It began ponding right near the intersection of these two segments. The lava flows in this area reached 15 to 20 meters thick in some places, and I'll show you a Met Office map of that here in a second. And there was concern that it might overspill the defensive barriers here. What it ended up doing was it overflowed. You know, the lava is going to follow the path of least resistance going downhill, following gravity. And this quarry right here called Melhol, I believe it's the name. And this is a quarry where they had been using some of the materials here to actually build the berm. It was also used probably for the road construction and as a road base and construction base material. But this was I don't know exactly what the material was, probably just some sort of aggregate, maybe some cinders. It's associated with Hagafelt, which is this subglacial volcano here, so some cinder, like loose basaltic material. Anyway, this quarry, obviously in the process of quarrying this out, they had constructed and excavated a bit of a low area here, and the lava actually poured down into that. There was some really nice footage of that, of the lava just kind of cascading down the walls. It was an lava flow, so it was kind of rubbly and more of a viscous type of lava flow. But this quarry is now completely filled in, so I'll have to get an update of my flow field map that will extend this blue area out into this region here. This quarry was completely filled in. Luckily, the flow didn't advance any further to the west, so it did not impact the roadway. But this is the area, the region in here, where the lava has been ponding for some time. So they're going to have to look for, you know, as they look to heighten and build up the defensive berms higher. That's sort of the game you have to play here, is as these lava flows right up against the defensive berm and inflate and raise the topography, that necessitates that you have to continue to raise the berms to some degree in order for the next lava flow or eruptive event to not ride over the top of them. And luckily, there are a few more quarries in the area. I remember driving past these two on one of my trips to Iceland, and you know, I was kind of looking at them like, hey, maybe I could go in there and check out some rocks. But there's this one here right along that south coastal road, and then another one right here just before you get to this area here. I've actually hiked down to this beach, and this is another subglacial volcano called Festarfjall, and this has a spectacular dike cutting up through it, just a really scenic little spot there. But anyway, those are two possible locations where they might be able to quarry out some additional material as they raise these defensive walls and berms here. Okay, so let's go to the Met Office, and let's actually look at that map just while we're talking about where it was ponding and such. So this is a map showing, and this is from a while ago, but I think it's from March 20th. Maybe about a week ago, but I think it reflects overall the thickness of the flow. So this is the thickness of the lava flows in different areas of the flow field, and just to make that a little bit bigger and scooch it over a little bit more. So the vents here are nicely defined. You can see these darker areas here where the lava is thicker. That shows where these southernmost vents have occurred. And then as the lava has flowed out of these southward vents, you can see a little bit of thicker lava flow here out of these two vents. But these vents here have created this lava channel. There was a channel of active flowing lava, or what some people might call a lava river, that had poured down to this area. And this is where the ponding was occurring. So you can see more or less here, excuse me, where the lava had accumulated, slowed, stalled, but more lava being supplied into it allowed this thing to thicken considerably. And then at some point, and this again is only good as of last Tuesday, or Wednesday, I suppose. Wednesday, the lava spilled over, riding over the January 15th flow, and then that quarry is somewhere about right here, and so it filled in that quarry area here. So this will have to be amended, and I'm sure we'll get a updated map at some point that might show this little flow lobe here. At this point, they might be waiting for this eruption to completely be done before they do any more updates to the flow field map. So let's look over the Met Office information as well a little bit. This is their last update. So this is from a few days ago. They haven't updated it since, I guess this would be Monday. They'll probably come out with another one today, I would guess. So the main issue here in looking at the Met Office update has been the gases have been pretty bad. So they've been actively monitoring the sulfur dioxide concentrations, the gas emissions coming out of this area with this vent. And so the concentration is very unhealthy. The eruption seems to have subsided. And the main issue here has been that the winds have been fluctuating a little bit. So at times this gas has been concentrated or moving into the area around Grindavik, and so they have had, I believe, a few days and possibly still going on where they've not allowed people in there just because the gas concentrations have been high. Remember that these volcanic gases are quite dense, they settle, they stay close to the ground, and so the shifting winds can kind of carry them into other areas, which makes it very safe and unhealthy. That's one of the reasons why they are not allowing people close to the eruption site. Among other reasons is the gases are flowing out of these vents, which are up on the slope, downhill towards the coastline, or in some cases they've moved over towards the west. I believe they've had some incidents at the Blue Lagoon, the power plant, with people having some either respiratory issues or some sort of health issues with respect to the gas concentrations there. So the Blue Lagoon is still closed. And so, yeah, and so if you're wondering why, why can we not access this area? Why can tourists not hike in here now that this thing is flowing and watch it? I would say the gas concentrations are probably one of the hazards that are prohibiting that. And then just the chances of breakouts happening when you get lava ponding in an area, but lava is continuing to be supplied to it, especially if that area is in an uphill environment like we see here up against those two segments of the defensive berms, then you can sometimes get lava breaking out of that and starting to flow in different directions. And so it's not a completely predictable situation, and it's very different than about 2 or 3 years ago, or this past summer when we had all the eruptions at Fagradalsfjall, where all those vents and lava flows were confined to a valley. The gases were confined to the valley, so they sat in a low area. It was a much safer and more controlled environment to allow people to watch that eruption. So there's also limited roadways in and out of here. So anyway, so high concentrations of sulfur dioxide have been observed in recent days. It's unhealthy. You could have respiratory issues. In high doses, obviously, it can be much more damaging. Yeah, so this is mainly about the gas concentrations in the area, and so they're starting to monitor those a little bit there. Yeah, they've got some webcam footage of at night. You can just see these glowing little hot sections of the flow field. During the day, it all kind of looks black to the naked eye. So that's the Met Office update. I'm sure they'll come out with another one soon, but kind of running you through that. But the eruption is dying down as over this past 10, 11 days since it began. Interestingly, the GPS data, so now that we've got a good week or more's worth of GPS data since the eruption, and this is the Svartsengi GPS station that we've typically monitored here. So there's the uplift going into the February 8th eruption, the uplift and inflation leading up to the March 16th eruption. And now we have enough points here that we can see a little bit better trend to the data. And it does look like that it does have a very slight upward trend to it. So it's not nearly the same slope and uplift rate that we saw with all the prior eruptions. But since March 16th, overall, it looks like the area is having uplift. So that uplift then is interpreted as being lava inflation. So it's inflating or uplifting, but at a much slower rate than it did previously. And so that suggests that the influx of magma is still occurring and that it's also greater than the output of magma. So even though we have an actively erupting system and we're pumping a lot of lava out to the surface, we still have more lava or magma moving into the system from below. And so that suggests that some of the lava is being stored under the Svartsengi area, that it's not all making its way to the surface because we see this uplift trend here. And so this is interesting. There was talk at one point that, well, maybe now that this eruption has been sustained for a few days, maybe now there's a direct pathway from the deeper magma reservoir straight to the surface, and as long as if the output equals the input, then we should see no change, right? This would be a straight flat line. There should be no elevation change. But with this upward trend that we're seeing here, that's suggestive of a system in which there is more lava coming into the system than is being erupted. So it's interesting. The plumbing system of this volcano is definitely changed, I think. There's some different things going on that we'll have to try to figure out. Some of that deeper sourced magma may be making its way to the surface pretty easily, right to the vents that we saw in the webcam. And then maybe some of it's also being partially fed into this magma reservoir beneath the Svartsengi area. So is it all at one connected pathway? Are there multiple pathways that are either connected or maybe not so connected? Is there maybe more than one magma reservoir or body in the subsurface? And remember, we looked at these sills before, and a lot of times these sills aren't just one single sandwich layer that holds the magma. There's several thinner sills, and it's more about how interconnected they are as to how that magma might flow through the system. And so we might be seeing something like that. I'll try to put together, when I get back to the office here in a few days, I'll put together maybe a sketch or something that might just help us interpret and explain that a little bit better. In terms of earthquakes, we haven't seen anything big around in the Reykjavik area, as you might expect with this ongoing eruption. Mostly small earthquakes, low magnitude and low frequency, so not a lot of them. But there was an earthquake in another part of Iceland, right about here in the central portion of Iceland, at a volcano called Askja. And there was a Met Office update about this from yesterday. And so I guess on Monday, the 25th, if I got my days right here, there was an earthquake in the northwestern part of Askja. This is what it looks like from the air. It's actually a series of nested calderas. You can see these black circular outlines here. That's these calderas. So these are explosive eruptions in the past have created this network and this interconnected system of calderas. So they erupted so much material that there was downward collapse. It created these pits, and so that's why these are calderas. And so there was about a 3.5 at about 5 kilometers depth, and then there was a series of smaller earthquakes, some of which were 2 to 2.5, and about 30 total. And so it's probably not indicative of it preparing to erupt anytime soon, but it definitely warrants some monitoring going forward. And it goes on to say here, activity has changed a little between months and been fairly stable until yesterday. Last earthquakes over magnitude 3 were in January 2022 and October 2021. So a lot of times as these volcanoes possibly ramp up towards something happening, you'll see this type of activity. Again, just fits and starts, a flurry of earthquakes here, quiet for a while, then another flurry of earthquakes, and so on. But they have been tracking the ground deformation there, and it's been going on for about 2 years, since the summer of 2021. And so they've had steady uplift and movement. Here's the upward movement in this area since late 2021. So you can see it's starting to move up. There's some dips and rises in here, but there has been a net upward movement for about 2 years or so at this location. So what that means going forward is anyone's guess. Does it mean it's going to erupt anytime soon? I don't think so, but it's definitely one of the volcanoes among many that they're monitoring there, and this one definitely deserves a little bit of attention going forward. And so we'll continue to watch the earthquakes and ground deformation here, just like we did on the Reykjanes Peninsula, which obviously led to eruptions at some point. The eruptions here would be very different, though. So if we do get activity at Askja, it would be a very different type of volcano in terms of how it erupts, what it erupts, the strength and the power of its eruption would be much greater than anything we're seeing on the Reykjanes. So interesting. I'll do more on that later too once I get back. I need to do a little bit more research on that specific volcano. And then finally, this was a article that a viewer kind of keyed me in on as well. And it's a little rough on the Google Translate, so I'm not sure I understand all of it. But apparently, to the west of Grindavik, I think what they're concerned about perhaps is, let me get you to the right map here. I think there's some concern about, if the lava starts moving out along this western side here, if it kind of ponds, it already went into the quarry and it moves into this area here with the defensive berms, just some worry about those holding. And so another tactic that it looks like they're employing, in addition to the defensive walls and berms, is creating a channel. So it says here that they're using, and I don't know exactly, is it blasting like, explosives, or I don't know exactly what they're doing, but they're excavating the landscape and possibly using some explosives as well to create more of a channel to help direct that lava, if it were to occur there, out towards the coastline. So holes have been drilled into huge rocks that would have caused a possible lava flow to the sea. Parts of the sea have been, okay, they're talking about the landscape here. Have caused a possible lava flow in the landscape. Parts of the landscape have been blown away before the Easter festival starts. The idea is to carry out a large explosion in the area and thus remove about 5,000 cubic meters of boulders from the planned lava channel. Tons of explosives have been used during the construction. So apparently they're using explosives, and the idea here is they're just trying to excavate and sort of dig a trench, if you will, that goes off to the southwest and down to the coastline and tries to channel that potential flow. They apparently think that's going to be a pathway that a future eruption might take, would be down along this region over here. So we'll have to see how this looks moving forward. So, but that's a brief update. I just wanted to spend maybe 20 minutes with you here today putting this together. Sorry you can't see my little face there in the box, just trying to do this thing on a laptop, which is a little bit different. But I will be back with you soon. We arrive in New York later today on Wednesday, and then I'll be flying back to Idaho late on Saturday. So I could be with you on Sunday or possibly sometime this first week in April. So look for me soon. I hope you've all been doing well. I've got a few videos that have dropped during my absence. I hope you're enjoying those. There's another one that should come out this weekend. So please enjoy those, and I will continue to monitor the situation in Iceland. And thanks for your viewership and all your support, and we'll talk to you soon. Take care.